We're looking at a text by Professor Cornell Overbeck, The Mystery of the Missing Monocle. And I have to say, I'm not sure if I should be more worried about my own brain or the stability of the entire universe.
It's a heavy read. Overbeek isn't really interested in the cartoons you watched. He's using that collective confusion to connect two very different, very intense fields.
High-energy particle physics and existential philosophy.
Exactly. He takes a meme and he turns it into a diagnostic test for reality itself.
And he pins the whole argument on a very specific date, a date that a lot of people point to as the moment things felt different. July 4th, 2012.
The day Cern announced they'd found the Higgs boson.
Right. For most of us, that was just a science headline. But for some, and for Overbeek's thought experiment, that's when the timeline broke.
Or branched.
So, our mission today is to walk this line that Overbeek draws. We're going to look at the physics of the end of the world on one side.
And compare it to the psychology of the anxious mind on the other. And, frankly, see which one is actually scarier.
Let's start with the physics, because that's the big hook. The popular theory you see on Reddit is that when Cern turned on the Large Hadron Collider, they smashed protons together with so much energy that they, glitched reality?
Yeah, that's the gist of it, that they somehow shifted us into a parallel timeline where the Monopoly man just never had a monocle.
But Overbeek starts there, and then he just completely dismantles that idea.
Immediately. He points out that physics doesn't really do glitches like a video game. You don't just, change a logo.
Right. He has that really stark line. You do not misplace a monocle. You dissolve chemistry. You extinguish stars.
And that's the scale. The Higgs field gives elementary particles mass. If you actually disrupted it, even a little bit.
It wouldn't be a spelling error?
No. Matter as we know it would collapse. The forces holding your body together would just stop working. We wouldn't be here debating anything.
So case closed then. The fact that we're still here means the machine didn't break anything.
Well, this is where Overbeek pivots and where the text gets really, really interesting. He says, yes, the machine didn't break physics, but what if the vacuum itself is fragile?
Okay, vacuum instability. I had to read that part a few times. We're not talking about a vacuum cleaner, right?
No. In physics, the vacuum is just the baseline energy state of empty space.
The floor of the universe.
Exactly. Think of it like a ball rolling down a hill. It wants to settle in the deepest valley possible. That's the true vacuum, maximum stability.
And we always just assumed we were already there, in the valley.
We did. But recent measurements, specifically of the Higgs boson and the top quark, they suggest something unsettling. We might not be at the bottom.
Wait, so where are we?
We might be on a little ledge, just above the main valley, a false vacuum.
So we're camping on a cliff edge, thinking it's the valley floor.
That's a great way to put it. We're stable for now, like a rock balanced on a ledge. But quantum mechanics says there's always a non-zero chance of tunneling through the barrier.
Tunneling? You mean just slipping through the floor?
If a high-energy event happened, and this is where Cern comes back in, theoretically, it could nucleate a bubble.
A bubble of what?
A bubble of true vacuum. Imagine a tiny pocket where the universe finally falls down into that deeper valley.
And inside that bubble, things are different.
Very different. The laws of physics rewrite themselves. The fundamental constants change. Atoms fall apart. Chemistry as we know it becomes impossible.
In this bubble, it would spread.
It would extend outward.
How fast?
At the speed of light.
Oh, so you'd never see it coming.
Never. That's the efficiency Overbeek talks about. One moment you exist, the next the information that constitutes you is just gone. Hard to delete.
Okay, that's a nightmare. But again, we're here. It's been over a decade since 2012. The bubble didn't happen.
In this timeline, yes. But this is where Overbeek brings in the many worlds interpretation of quantum mechanics. It's the twist that connects the end of the world to the Monopoly man.
The quantum survivor theory. Okay, walk us through this, because this is where my brain starts to tie itself in knots.
So, in the many worlds view, every quantum event doesn't have one outcome. It has all possible outcomes. The universe constantly branches.
So in one branch I wore a blue shirt, and another I wore red, that kind of thing.
Precisely. Now, Overbeek asks, what if, in 2012, the universe was in a really delicate state? And what if, in the vast, vast majority of those branches, the LHC experiment did trigger the bubble?
So in like 99.9% of the possible timelines, Earth is just gone.
Instantly. Those branches are dead, silent, no observers left.
Well, we're still here.
Right. And by definition, you, as an observer, can only find yourself in a branch that's capable of supporting you. This is the anthropic principle,
It's a selection bias.
a massive one. You aren't aware of the billions of branches where you died. You're only aware of the one where you didn't.
That is terrifyingly logical. It's not that we got lucky, it's that we only exist in the version of history where the luck held out.
Exactly. We inhabit the surviving branch. We didn't leap from a dying universe to a living one. We just persisted in the only place we could.
Okay, but how does that explain the monocle? If I just survived a cosmic apocalypse, why would I notice a change on a board game?
Because, Overbeek suggests, the surviving branches are infinitesimally nearby the dead ones in the mathematical space of all possibilities.
So our timeline and the one that blew up are neighbors.
Almost identical twins.
Huh.
Same wars, same presidents, same embarrassing emails you sent in college. But because of chaos theory, there are tiny, tiny divergences.
The butterfly effect.
Right. And maybe, just maybe, in the timeline that was statistically most likely, the one that blew up, the Monopoly man did have a monocle.
But that timeline is gone.
It's gone. It ended in 2012. And in this specific, narrow sliver of reality that survived, purely by chance, the branding meeting in 1935 went a different way. Or an artist made a different choice.
So the Mandela effect isn't a glitch, it's a residue, a fossil.
It's us realizing that the details of our world are arbitrary. They were only selected because they happened to exist in a timeline that didn't lead to total extinction.
That reframes the whole feeling, doesn't it? That unease people feel, that things are slightly off. It's not just confusion, it's almost like survivor's guilt on a cosmic scale.
Overbeek calls it the silence of the dead branches. We feel the weight of the probabilities that went the other way. We subconsciously know we shouldn't be here, statistically, so when a detail conflicts with our ghost memory of the more probable timeline, we feel it.
It's a really compelling narrative. It ties everything together perfectly. But, and we have to make this turn, he admits it's a perfect theory in the worst way. It's unfalsifiable.
Completely.
Yeah.
You can't test it. By definition, we can't access the dead branches to check. Everything looks normal except for a few tiny details. Is totally indistinguishable from everything is normal and your memory is bad.
And as a journalist, I know which of those is usually the safer bet. So let's talk about the boring answer. Why do I swear he had a monocle if he never did?
This is where we shift from physics to neuroscience. Overbeek talks about something called schema bleed.
Schemas are like mental blueprints, right, for concepts.
Exactly. Your brain doesn't store memories like video files. It reconstructs them. When you think rich banker from the 1930s, your brain pulls up a schema.
And what's in that schema?
Top hat, tails, a cane, a mustache.
And a monocle.
And a monocle. Think of Mr. Peanut from the Planters ads. He wore one. It's a visual shorthand for old-timey wealth.
So my brain isn't retrieving an actual image. It's retrieving the concept and then filling in the blanks.
It's using autocomplete. It pastes the monocle onto his face because it fits the pattern. It's a predictive error, not a cosmic shift.
It's photoshopping my own memories to make them make sense.
And here's the really profound part. Overbeek asks why we fight this so hard. People get genuinely angry when you tell them it's just a memory error.
Because it feels like an attack on your sanity, Mick.
It's an attack on our narrative. He writes, the anxious mind prefers a cosmic narrative to a cognitive bias.
Wow, that hits hard. If the universe changed, then I'm special, I'm a witness. My memory is perfect, it's reality that's flawed.
Preserves the ego, right. But if you admit it's just schema bleed, you have to admit your own mind is unreliable. That you can create memories that feel 100% real, but aren't. And that's a deeply uncomfortable thought.
So we have two options. Option A, we're quantum survivors on a rare, stable branch of reality, haunted by the ghosts of timelines that exploded.
Or option B, our brains are just sloppy data processors that care more about patterns than accuracy.
And Overbeek doesn't actually make you choose one.
No, he thinks the real value is in putting them together. He says both theories teach us humility.
How so? One is basically sci-fi, the other is cognitive science.
Well, physics tells us the ground beneath our feet, the vacuum itself, might not be solid. And neuroscience tells us our own identity, our memories, are also not solid. They're porous, revisable.
We're standing on thin ice looking through a foggy lens.
That's the takeaway.
Yeah.
The Mandela effect, whether it's physical or psychological, reminds us how thin the thread is between the world as I remember it and the world as it is.
And that brings it back to 2012. His final thought is that the year feels strange, not because the universe had to have changed,
but because we glimpsed how easily it could have. We peered into the abyss with that machine, we probed the very structure of reality, and even if nothing happened, the psychological weight of that what if It changed us.
The sheer fragility of it all.
It is. We realized our existence is just far more precarious than we like to admit, whether that's because of the Higgs field or our own faulty synapses. The result is the same. We are not on solid ground.
You know, at the end of these deep dives, I usually want a clear takeaway, like eat more fiber or something. But today it feels more like you might be wrong about everything, and that's okay, because at least you didn't dissolve in a vacuum bubble.
It's a lower bar for success, for sure.
Yeah.
But maybe we should be a little more grateful for this specific monocleless branch we ended up in.
Absolutely. I will take a typo on a children's book over total cosmic annihilation any day of the week.
I'll second that.
And for you, the listener, next time you swear a movie line was different, maybe don't panic. Just take it as a reminder that you're still here, surfing the only wave that didn't crash. Thanks for surviving the probabilities with us.